Okay, let's take a look. I do want to say some students were asking about, I don't know, a study guide for the midterm exam, which is coming up next week, about a week from today. I've posted some information, and I will talk a little bit more about this on Friday. So just hang on. I mean, you can take a look, but I will cover more information about the midterm exam on Friday. All right, let's go ahead and take a look at today's topic. So on Monday, we introduced S3 as the object-oriented, one of the object-oriented systems in R. And I didn't cover every single slide, but please make sure you do read through the slides in that lecture and familiarize yourself with the content there. And today we are going to look at the R6 object-oriented system within R, and this is this implements encapsulated OOP. So on Monday I talked about there's generic function OOP, and then there's encapsulated OOP. So S3 was a generic function OOP system, and R6 is an encapsulated OOP system. So let's talk about that. All right, so as I just said, R6 uses the encapsulated OOP paradigm. And so what this means is that the methods belong to the objects and not to the generic functions. And you call them by using object, and for R6, you call them by doing the name of the object, $, the name of the method. R6 objects are mutable, and that means they are modified in place and they have reference semantics. So I will talk about what that means exactly. R6 is not part of base R. You have to install the R6 package, and then you would call library R6 to load it up. Okay, so that's that. So let's talk a little bit about how some of this stuff works. So the way we would create a new object class in R6 is we use this function R6 class. Okay, capital R6 class parentheses, and that is really the only function from the R6 package that you will use. Okay. And this defines a new R6 class, and when you define a new R6 class using that function, basically all of the kind of R6 reference semantics and all of that get implemented. When you use that function, you need to provide it at least 2 arguments. The first one will be the name of the class. Okay, so this is the name of the class you're creating, and by convention, R6 class names use upper camel case. Upper camel case basically means the first letter is capitalized, and you don't use underscores. And to kind of indicate that you have new words is you capitalize each new word. That would be upper camel case versus snake case, where you use underscores to separate out the words. So the first argument will be the name of the class. The second argument that you have to at least provide to an R6 class object, or the R6 class function to create a new class, is a list that you call public. Okay, and the list is going to contain methods or functions as well as fields. Okay, basically places to store information that belong to the object, and those methods and fields use snake case. And when you do R6 class, you should always assign the result of R6 class into a variable with the same name as the class. And what that will do is it will define an R6 object that defines the class. So let's take an example here. So here we are creating a new R6 class, and there are 2 arguments that I'm providing. One is the name accumulator, capital A, right, using upper camel case, and then the other is a list that we're going to call public. We store the result of this R6 class function into an object called accumulator, which takes the same name, same spelling as our class name. Okay. All right, and within this list for public, I have one field, sum, which currently contains the value 0, and then I have one method, which is a function. Okay, and we'll talk about what happens inside this function. So this creates a very simple class. The class is called accumulator. It has one public field, sum, and it has one method called add, and that add is going to add x to the sum. And then once you've defined that class, okay, now we ask, what is accumulator? It says accumulator is an object generator, and it generates objects of class accumulator. Within public, there's the field sum, the method add. There's also a method clone, okay, which we did not define, but just comes with any R6. Anything that's R6 class will always kind of come with this clone method, right? And it has other information here. You can create new objects of this class by calling the new method. So here, I'm going to call accumulator. All right, so this is the class that I've defined. And again, we did not define this method new, but we can call accumulator $new, and this will create a new object of this particular class. And so x is, so I'm going to say accumulator $new, and x is now an accumulator class object. All right, so that's different from accumulator itself. Accumulator is the object generator. Accumulator is the class definition. Anytime I use accumulator $new or whatever, we're going to create new objects of this thing, right? So it's kind of like human being is a class, right? And then each one of you is a particular instance. Is a little bit of a weird thing to say, but each one of you is an example of a human being, right? So you have the human being class as like these are we're that, and then each individual person, so in this case our x is an example of the accumulator class object. You each are an example of the human being class of, I don't know, being, I guess. Okay, so that's what we have. So x is an accumulator class object, and it says inside the public things that are available to us publicly, we have the add function, a method, and then we have the field sum. Okay, there's also the clone method. And to access any of the values in x, okay, and at least any of the public values, we just do x $sum, and it says, oh yeah, the value of x $sum is just the number 0. Okay, and we can see this is just a regular old vector with one number in it, value 0. And we can say, let's call the method, okay? So we ask, what's the sum? Sum is the value 0. X $add is the method, okay? We reference the method, and this is a function, and we know it's a function because we're using parentheses here. And what add will do is it's going to add 1 to the sum, and then so we ask, hey, what's the sum now? The sum is now 1. We can say x $add 3. And what that's going to do is it's going to add 3 to the sum, and we say, hey, what's sum now? Sum is now 4, x $sum. Okay, so we're just kind of, this is a very simple class object. There's just one number in there, and then we're just adding values to it. Okay. So what's happening in that method that we've defined? Okay, so the method, okay, the method $add. It's a function, and what it's doing is it's returning, okay? The very last line is the object that it returns. It says return invisibly itself, okay? Which is a little bit of a weird thing, but that's kind of the recommended practice when you do R6 methods. And so how does this work? Okay, so we in R6 things, you reference the object itself using self, okay? So as far as the function goes, okay, the default value is 1, and what it's doing is it's saying, okay, what is the, we take our self and we say, okay, what is the value of sum, which is the field, okay, in this object, and we're going to take that value, we're going to add whatever number x gets passed, so by default 1 or any number we pass to it, and then we store that back into self $sum. So we update self sum, and we're basically adding x to it, and we're storing it back into self $sum, and then we return the object itself, okay? And we return this invisibly. And returning it invisibly basically just means, when you call the function right here, it doesn't print anything out. Normally, if a function returns something, it kind of just prints out. Here we're saying do it invisibly, which kind of says it's not going to be printed out. Okay. Now, because the object itself is returned, that allows us to kind of chain methods together, right? So, for example, I can say x $sum, and currently the value is 4. And I can do x $add 10, okay? Now, this itself returns itself, okay? So from here to here, we are returning the value, the object x itself, okay? Now, after we've added 10, so the sum is currently 14. And then we can call $add again, so we're adding another 10 to that, okay? And then we can ask, all right, and then what's the sum of that? So the sum there is now going to be 24. So here this is very simple, but I basically changed the method where I don't have to say, okay, x $add 10, and then come back later and do x $add 10. I can do x $add 10, $add 10, and continue chaining methods. $add 100, $add 3, whatever, and then we can kind of ask what is the sum after that, right? So again, that's because the method itself returns itself invisibly. So this that call returns the object itself after running the add method, and we can run the add method or any other method that we've done before. If you've ever used Python, this kind of object chaining might be familiar. In Python, we use dot notation, but you might do something like list dot append dot sort dot you can take these like a pandas data frame, and you can kind of chain a bunch of these methods one right after the other. And similarly, we can do something similar here, but instead of the dot, we use a $sign to kind of chain methods. All right. So for readability, it's sometimes recommended that you put the chained methods, you put them on their own line. So here I have x $sum, currently 24, and I can kind of chain the add 10 and do $add 10 $sum, and now it says 44 here. 44. Okay, let me go ahead and give you your first view quiz answer. Today, the first view quiz answer is the letter B. B as in bear. B as in bear is our first view quiz answer. Okay, let's say we want to do something just a touch more complicated. And so here, when we define our list of methods that go into public, we're going to add a function called initialize. And what initialize will do is it will override the default behavior of $new. So $new is used to create new instances of that particular class, okay? And what initialize does is it allows you to basically define, say, required fields, or to kind of perform some kind of validation to kind of make sure the inputs are valid, okay? Otherwise, $new is just going to kind of create a new instance with, like, you're not accepting any kind of new information. It's just you're basically taking that class object and creating a new instance of it, and you have to kind of set it here. Okay, so I've taken this example straight from Hadley Wickham's book, and so he defines a class person. Okay, a person class object. So we see class name is capital P person, and we're storing this into an object called person. All right, and then as far as the other argument that we have to provide, which is a list that goes into public, okay, this list has two fields, a name and age, okay? And so name and age, and that, right now they start off kind of blank and missing, right? So no value for name and missing for NA. And then, and what's the method we're gonna use, okay? Well, we want to, when we create a new instance of a person, we're going to require that we get a name and we get an age. We're going to require these two things in order for us to create a new person. All right, so how do we do that? Well, when we create a new person, we're going to call $new. We're going to do person $new, and when person $new runs, it's going to execute this function initialize. And so this function takes in two arguments, name and age, okay? And there is a default value for age. So even if age is not provided, it will kind of put something in there, okay? So, and we're gonna run stop if not, okay? Stop if not basically throws an error if any of these things are false. So is name a character vector? So that must be true. And then the length of that name vector has to be 1, okay? And then it's going to ask, is age a numeric thing? It's going to return false. So I think actually right now this NA is logical, so that this might be false, okay? And then the length of the age vector has to be 1. And then if these things pass, then we will take name and update self $name with that name value, and then self $age with the age value, right? And that's the end of initialize there, okay? So here we will say we're going to try to create a new person where the name is Hadley and age is equal to 38. And this says, no, that's not going to work because is numeric age is not true, right? So this throws an error, and so that doesn't work, okay? Here, if I do person $new and we're going to do Hadley age equals 38, this works, and Hadley right here is now an instance of the person class object. Okay, so here is, if we say, okay, what does Hadley look at like? This is the default behavior for printing out R6 objects. So here, this is kind of just the default printing thing. It says, okay, Hadley is person class object, which is denoted by kind of these the angle brackets, or the less than greater than here. And the public values are age 38, name Hadley, and then there's two methods: the initialize method, which gets used with new, and then the clone method, which comes with kind of all R6 objects. And if we don't like the way this prints out, we can define a print method, okay? And so we're going to define a print method to change this. And so my definition just kind of gets bigger now, all right? So inside the public list, we have the same functions. We have same two fields, name and age. The initialize function is still the same as before, but now I am adding a print function, okay? And so this print function will get executed anytime we ask for the object to be kind of printed out. And so, and all this is going to do is it's going to cat person to the screen, cat space name along with self $name, and then space age with self $age, and it will also return itself invisibly. So, we could chain things if we needed to. So now, because I've redefined the person class, I have to create a new instance of this. So I'm going to create, again, Hadley 38. We're going to store this into an object called Hadley2. And so now when I print out Hadley2, it runs that print method, which has, person and name and age, catted this way, and that's what we see. Okay, so we can see this runs exactly as we requested. Now, again, the methods themselves are bound to the objects. So so here we've defined a person class object, right? And then earlier back here we defined a person class object. Okay, so these person definitions, what does it mean to be a person? This got updated. Okay, so the Hadley over here was defined under this definition of what it means to be a person. Okay, and Hadley 2 was defined under this definition of person. Okay, and so when we look at these objects, okay, Hadley 2 gets printed out using the updated method, okay, for print, whereas the original kind of Hadley object still prints it out the old way because this was created under the old definition of person, right? It's a little bit of a weird concept, but but the methods, like this print method, is defined to the kind of that object itself, the object that was created. And so Hadley over here was created under the older definition, and so therefore the print method still uses that older definition. Okay, it's not like when you redefine person, it's going to redefine all of these past instances. Okay, it's just once you've created a new definition, then that will be used going forward, but it's not going to go back in time and update everything in the past. You have to kind of recreate those things, or just kind of accept that they still use the older definitions. So so this older object Hadley doesn't get the new print method here. It's also important to note that even though they happen to have the same class name of capital P person, there's no relationship between these two objects. Hadley was defined under the old definition. Hadley 2 is defined under the new definition. And, as far as they're concerned, those are two totally different objects, two totally different definitions. They just happen to have the same class name. And so one thing to kind of remember and keep in mind is that if you are developing a class definition, it can be confusing if you kind of create a class name and then later on update it and stuff like that. So anytime you update the definition of a class or something, it's probably a good idea to kind of delete all of the objects that have the old class definition, so you don't kind of confuse. Or if you're writing up a script, define all of the definitions first and then create the instances. You don't want to kind of define, create instances, redefine, or something like that. So as in development and whatnot, there's kind of this going back and forth of like, okay, I've got to do this, and I've got to update this, and I've got to do this and that. So just again, get in the habit of wiping out your environment. And I know I said that during the first week, and a lot of you are listening to that advice, but a lot of you, not you particularly, not like the 8 of you here, but when students come to office hours and ask for help, and I kind of just take a peek at, they share their screen with me, not everyone's following the advice of kind of clearing out the environment. So it is a good idea to kind of clear out the environment, and that's going to become especially important when you're dealing with something like R6 definitions, where whatever object you create gets created under whatever definition that you had. Okay, and so I will post homework 4. I know you guys are just wrapping up homework 3, or you just did that, but homework 4 will come along. Homework 4 is going to make use of R6 classes, R6 things like that. And so to make your life easier and better, follow this advice, okay? Anytime you redefine, anytime you add something to your R6 class, delete the old object and create a new instance of that object using the new definition. Otherwise, you're gonna run into frustration of like, why is my thing not doing what it's probably operating under the old definition, stuff like that. Okay. It is possible to again to modify the methods of an existing class, and you can do something or update the field of an existing class definition. And so here you can use something like $set. And so here I'm redefining accumulator, okay? And technically here I'm just giving it the name accumulator, and I actually haven't given anything in public, okay? And now now that I've defined accumulator, I'm going to set public, and we're gonna set the field sum equal to 0, and then we're gonna set the method add, and that's gonna be equal to a function here, right? And again, so this is basically redefining what it means to be an accumulator class object. And so if I wanted to use this, I have to kind of redefine, recreate instances of this accumulator class object. So, earlier we had an object X where we added, 4 and 10 and, we had 24 and 44 and whatever to that accumulator class object. That's still defined under the old definition of accumulator, even though this new definition of accumulator is exactly the same. Like I didn't change it, but this is technically a new definition here. Sometimes you want to have a related class, and so you can have one class inherit from another class, right? So again, if you think about animals, we can say, all right, we're going to create a new thing, a dog. Okay, dog will inherit basically properties from mammal, okay? And mammal inherits properties from vertebrates. Vertebrates inherit properties from animals and stuff like that, right? So, animals have like animal cells which contain mitochondria and things like that, versus something like, plants which have, different kinds of cells. I don't remember biology stuff, but we learned it's like a meme now, right? Like mitochondria is the powerhouse of the cell or something. But anyway, so mammals, dogs, have animal cells with mitochondria, and dogs, are mammals, so they, inherit, basically a lot of the kind of features that mammals have, fur and I don't remember all of the what defines a mammal, but basically you can do that, right? And so here we are going to create an object, the chatty accumulator. Okay, so I guess there's a programming convention where you have like a chatty or a verbose version of something, and that basically just kind of the verbose version takes something and just continues to output stuff onto the screen. So you kind of experienced this a little bit in your second homework where you did chutes and ladders, and you had the verbose, which was saying like, okay, this is exactly what's happening every single step along the way in terms of like rolling the dice, and then you have the the quiet version, which just says, okay, this is how many turns it took to win the game. So here we're going to have the chatty version or the verbose version of the accumulator, and to say, we're going to inherit everything from the accumulator class object. So we're going to say accumulator chatty inherits from the accumulator. Right now the accumulator has the sum field and the add method, and here we are going to update the add method, and the add method is going to call cat, okay, and it's going to cat adding X to the screen, and then to indicate and this is such a simple function, I could have just done self $sum plus X, but what do I do here? Here we are going to call super $add. And this calls the method that's defined in the superclass, right? So accumulator chatty inherits from accumulator. So in this case, accumulator is kind of the parent or the superclass, and accumulator chatty inherits from it. So we're going to say, because you could imagine you have a method that's really complicated, and rather than having to copy and paste all of that code and stuff, basically all we're saying is when we run the add function, basically run the same add function defined in the parent class, but all we want to do is just make a small modification, which is just run this one line of code that says cat before you run that add method from the parent class. And so here we call super $add. And so when we do that, I'm going to create x2. x2 is a new instance of the accumulator chatty class. And I'm going to call x2, so it comes in, when we create this, it inherits everything from accumulator, so it starts off with a default value of 0 for sum. And we're going to say add 10, add 1, and return the sum. And so when I call add 10, it executes adding 10, a cat adding 10 to the screen, and then it calls super where it adds 10, so it uses the parent class method of taking 10 and adding it to the self $sum. And then we have add add 1, and it cat's adding 1 to the screen, and then we finally ask for the sum. Okay, is that all right? The use of super and calling the method in the superclass or the parent class here. I hope that's okay. Let me go ahead and give you your second view quiz answer, which is the letter D. D as in dog. D as in dog. Okay, and so the text got a little bit cut off here. So we're defining a method add, and this is going to override the add method in the superclass accumulator. And again, we are making a call to super $add. So that's all we're doing. All right, when you call class, so in S3 you can call class on an object, and it will tell you what kind of class the object is. And here again, does the same kind of thing. And if you are using an R6 object, it will give you the name of the class, and all of them will be a vector, and the last value in the vector will be R6. So Hadley, its class is person, and it's R6. Now again, this definition of the person class is different from Hadley 2's definition of the person class, although their class, the vector of class names is the same, okay? And again, this is bad practice to have objects defined under one definition of person class and other objects defined under a different definition of the person class, because again, this is confusing, right? Unless you knew exactly what code was run earlier, you would not know that Hadley was defined under a different definition of person class, and Hadley 2 was defined under another definition of person class. So again, there's no R doesn't require you to delete all objects of the old class name. So again, you have to kind of be vigilant and do this yourself, so you don't confuse yourself later where you have objects defined under different definitions. X2, remember, inherited. X2 is an accumulator chatty class object. The accumulator chatty class object inherits from accumulator. And so you see this vector value is accumulator chatty, accumulator, and again, all of these things inherit from the R6 class definition. So, everything that's R6 comes with, reference semantics. They all kind of come with a method new and a method clone and things like that. But that's what we have here. You can also see what are the methods and the fields available inside an object. So here we can say names Hadley. So again, Hadley was defined under the old person class, and we see there is the age and name fields. There's the clone method, the initialize method. Okay, now all we just see are the names. Basically, just the names of the objects in the list. We don't actually know which ones are fields and which ones are methods based off of this. We see under Hadley 2, there's a print method defined, x2 we have sum and add. Everything kind of comes with clone. All R6 things will come with clone. Okay. When I introduced R6, I said these things come with reference semantics. Okay, and reference semantics is something that perhaps we're not usually accustomed to in R. Okay, so most things in R are copied on when we modify them. Okay, so R uses something called copy on modify, and this is kind of the behaviors we're accustomed to. So for example, here I create a vector containing the values 1 and 2. We're going to bind the name A to it. So A points to this object in memory which contains the values 1 and 2. Then we're going to bind the name B to A, all right? And so B and A are both pointing to this object that contains in memory that contains 1 and 2. And then what I'm going to do is I'm going to say, you know what? Take subset B, add 10 to it, and store it back into B. And here in R will execute a copy on modify. It's going to, when we do this, R is going to create a copy of A and create a separate object of B. And so when we ask what is A contains the value 1 and 2 as we originally defined. And B contains the value 11 and 2 because we changed the first value in B to 1 plus 10, which is now 11. And I don't think this is surprising to anyone, right? This is kind of the behavior that we're expecting from R. We said, okay, I've added 10 to B1, and we don't expect A to change during this kind of operation, right? So this is how R behaves, where when we do this thing, R creates a copy of it. And so A remains 1, 2, and is untouched by kind of this operation that we did when we modified B. B becomes 11 and 2. That's the copy on modify, and that's what we have there. R6, on the other hand, have reference semantics, and objects are not copied when we modify them. So here, what we're going to do is we are going to create a new instance of the accumulator class object, and we're going to call that X. We are going to take Y, and we're going to bind Y to the same object X. All right? And so this is something. So when we start off with a new object, what's the value of sum? Sum starts off at 0. Here I'm going to add 10 to Y. Okay? When I add 10 to Y, the name Y is pointing to the same object in memory that the name X is pointing to. These are not different things, and when I modify Y by calling add, I'm not going to create a copy. And so I added 10 to Y, so notice I call Y $add 10, but what happens? X $sum is 10, and Y $sum is 10, okay? And it's not that X also got modified, it's that X and Y are the exact same object. Okay, X and Y are pointing to the exact same object. So when you do Y $10 and X, basically this is like a nickname. Okay, Y is like another name for X. So when you talk about Matthew and Matt, and you say, okay, I gave $10 to Matt, you're giving $10 to it's Matthew also is the same person, right? So these are we're referring to the same object here, right? And that might be that's different from what we're generally accustomed to in R, where we have this copy and modify thing where originally we bound B to the name A, but then when we modified B, we got a copy of it, and so we end up getting different values here. Over here, we don't have this copy on modify business, and so changing Y is the same thing as changing X. If you do want to copy, okay, and you don't want if you want Y to be separate from X, right? So if we do this, Y is the same thing as X. Here, if we want Y to be a copy of X, then we use the clone method, all right? And so all R6 objects, whenever you create a new R6 class or whatever, it will always come with the method clone. And this allows you to create copies of objects so that they will be separate things. So here I'm going to create a new instance of the accumulator, and we're going to call that x. And I'm going to clone x, right? So y is not the same object as x, it's a clone of x. So I can add 10 to y, and x still has a sum of 0, and y has a sum of 10, right? So I want to make sure we recognize that these are very different kind of things going on. This one, y and x are pointing to the same thing. Here we're making a clone of x, and so that's reference semantics. And again, we're not generally accustomed to this in R because R kind of always does this kind of copy on modify business. And so this is something that you have to get used to or keep in mind whenever you're working with R6 objects here. Okay. Now, so reference semantics can be a tiny bit tricky. Okay. So here I've got x is going to be a list where a is equal to 1. Y is going to be a list where b is equal to 2. And z is going to be a function that takes in argument x and argument y, right? So here, when we run this function, okay, we know that x is going to remain unchanged, y is going to remain unchanged, and the only thing that's going to change is going to be z, right? So that's how normally things work in R. We don't have to worry about x and y changing when we run some kind of function like this. Okay, here, what happens? So here I'm going to create, so we're going to just imagine having an R6 class. R6 class called list. So x is a R6 object, y is an R6 object. And now I execute this function, x and y, okay? Now x and y go in as inputs for f, and within this function f, we don't know the code inside f. There could be calls such as, y $add or x $add. There could be calls inside this function f that actually modify x and y directly, okay? So this function seems to return some value that will get assigned to z, but when you execute this function, we don't know if x and y are going to get modified as part of the function running, okay? And that's where reference semantics get tricky, because as you're kind of running, reading your code and trying to debug, like later on you say, hey, how did my x get this value, right? Why is my x showing a value 15? I don't remember ever changing it to 15, okay? X, containing a inside of x now has 15 or something. When did that happen? Okay, it could have happened when this function over here ran, right? And that's a little bit harder to spot when you're reading the code, because now you have to remember every single thing that happens inside of a function, okay? And that's just really hard to do, is just to remember every piece of code. So when you're reading your code, you want to have it kind of simple and know things. And so a tip to help you avoid this kind of thing is you should your functions should only do one of two things, okay, and not both, right? One is it returns a value, okay, kind of like this. The function returns a value that you're going to store somewhere, and then you say, okay, when I'm seeing this function run, it's going to return a value. Anytime the function is going to return a value, it should not modify any of the objects, the arguments going in, okay? Or the function modifies the objects or things going in, but it doesn't return a value, right? And if you kind of make sure that your functions only do one, but not both of those things, then that will help you read your code and understand it, and not get kind of confused later, right? And when you start doing both of these things at the same time, that's when it gets a lot harder to read. So for example, you see this y $add 10. This does not return a new object, okay? So when we see this, we can say, okay, this is modifying y. This is modifying y. As we're reading this code, we know, okay, this is going to be modifying y. When we read this, because we see this operation, we say, okay, this function f is returning something, and we would anticipate that it doesn't modify x and y. With reference class things, it's possible to write a function that's going to do both of those things, but but you shouldn't do that because it just gets confusing, right? It's kind of so here's an example. So this is an example of a function that modifies the object in place. It doesn't return something. So we're going to say add 5 to the sum is just going to take the accumulator class object and call add 5 to it. So we say add 5 to the sum, x adds 5. Okay. This one over here is going to take the sum and multiply it by 10. Okay. And so we do accumulator $sum times 10, and this will return a value. And so we can see, okay, this returns a value, and so we're going to store that as y is 50, and because it's returning a value, it's not modifying any of the values inside, and so x $sum, sorry for the text here, x $sum is still 5. Okay, so these are just two separate examples there. Okay, I am going to run out of time. Let me go ahead and give you your last view quiz answer. The last view quiz answer today is A. A as in apple. A as in apple. All right, and the last section in today's lecture is on public, private, and active fields. Okay, so I will not put any of this stuff on the midterm exam. All right, so you can expect R6 kind of stuff to appear on the midterm, but I won't test you on any of this public, private, and active things. Okay. So far everything we've seen was in public fields. And public basically just means that those values are, and fields and methods are available from outside the function, okay? You can also create a list of fields and methods inside a list called private, okay? Private means these values are available only within the object, okay? And you can't access them from outside, okay? Now, private does not mean secret. It just simply means you can't directly access them. So don't use private as a way to like hide passwords or something, okay? It's not encrypted, it's not secret. It just means you can't access these values from outside of the object. They're only available from inside the object, okay? So this was kind of our definition of person. We said public, and inside public we had name and age. And what we can do in here is we have, okay, Hadley to $age is 38, but if I wanted to, I can just take Hadley to $age and assign 25 to it, okay? And now we've modified that field age, all right? Because age is a public field, we can access it from outside, and we can just kind of change the values from outside, all right? And maybe we don't like this, okay? So here, what I can do is I can, inside private, I create the name, age, or create the fields age and name, right? And what we will do is, in public, we'll be able to create new values, okay? Private name, private age, all right? So this, we're assigning the name and the age that comes in during the initialization to private $name and private $age, okay? So rather than calling self $name and self $age, we have private, okay? And then when we print, we can access those values, private $name and private $age, okay? And basically now I no longer am able to access, say, Hadley $age. Hadley $age returns null. If I tried to change, okay, the value of age, okay, and if I say let's assign age, 25 to age, okay, I get an error. I'm not allowed to do that, okay? The values are still there, right? So the print method accesses the name and age values from private, and so we can get that. We just can't do stuff like this where we're just changing things on the fly from outside, okay? So the values are there. We can access them from inside the function or inside the object, but we can't access them from the outside, okay? And so those are private fields. I've run out of time, so you'll just, if you're interested in this thing called active fields, then you'll have to read it. Active fields, but just in summary, active fields will allow you to interact with stuff, okay? it basically allows you to define something that looks like a public field, but is defined by a function. So for example, let's say you did want to be able to access $age, right? Let's say we wanted to get 38, but we wanted to disallow changing it, okay? You can do that with something like an active field, okay? With an active field, we can say, all right, hey, what is the name? And it returns Hadley. But then if I wanted to change the name to something else, okay, if I wanted to change it to say some 10 like this, it says, I'm not allowed to do it. And these are defined using active fields, okay? And so again, I've kind of run out of time to go over that. I'm not going to test you on private and active fields in the exam or something, but we have that. Okay, we'll go ahead and end here for today, and we will see you on Friday. And I'll talk a little bit more about the midterm exam on Friday.